In this video, let's take a look at graphing sine and cosine. So cosine and sine are both derived directly from the unit circle. To graph the parent function, we're just going to take the cosine, which is the x value of each point, and it always starts with 1, and it looks like a u. And so we're going to take the 5 major points of our graph. So we have 0, we have 90 degrees or pi over 2, we have 180 degrees or pi, we have 3 pi over 2, which is equal to 270 degrees, and then back to 360 degrees or 2 pi. And so that helps us to graph a full rotation, one full rotation or period of the graph of cosine. So let's start with 0, and then we'll put pi over 2, because that's like our 90 degree mark. And then we need pi, because that's the next one. That's like 180 or 90 degrees more. And then 3 pi over 2 would be next. And then 2 pi, which is equal to 360. So to graph one full cycle of cosine, that's how we represent that on our x-axis on a straight line. But they represent the main points of our unit circle as we rotate around one full rotation. And then look at the x values to pick out the cosine. They're in alphabetical order, so cosine is the x, and think of sine is your y value. So at 0 or 0 pi, I have a cosine value of 1. So I'm just going to plot that right there at 1. At pi over 2, I have a cosine value or x value of 0. So I'm going to plot that at 0. And then at pi or 180 degrees, the cosine value is -1, because that's my x value there. 3 pi over 2, it's back up to 0. And then when you get back to 360 or 2 pi, the x value is back at 1. We can also write that down. So 0 started with 1, 90 was 0, 180 was -1, 3 pi over 2 was at 0, and 360 or 2 pi was back at 1. So notice that also looks symmetrical. It goes down and then back up. And it looks like a U-shaped graph when we connect the dots. So that's one full cycle of cosine. That's our parent function. So we could say that is f of x equals cosine of x. There's no transformations, and it's just one period of the graph, or one full cycle around the unit circle. So now let's focus on sine, which is a very similar method. We're just going to look at the y values this time. So let's put f of x equals the sine of x. Let's plot the same values on the x-axis. So 0, remember pi over 2, which is equivalent to 90 degrees. And then pi is equal to 180, 3 pi over 2, which is equal to 270, and then 2 pi. So we're going to graph one full cycle of sine. So this time we just have to focus on the y value. So we're going to put 0, then 1, then 0, then -1, and then back to 0 again. Because that represents one full cycle of sine, our y values. So 0, 1, 0. Let's write that. 0, 1, 0, -1, and then we'll come back to 0. So starting at 0, and then we go up to 1, back to 0, down to -1, and back to 0. So a sine graph looks kind of like an S that's turned sideways. So cosine is a U-shaped graph, and sine looks like an S shape. So those are our two main parent functions of cosine and sine. Let's look at a few more things on the next page. So we have transformations that go with sine and cosine, the same way they've gone with all of our functions in Math 3. So A is doing the same thing for sine and cosine that it always does. If A is negative, it's going to make this reflect over the x-axis. If the absolute value of A is greater than 1, then we have a vertical stretch by a factor of that number. If the absolute value of A is between 0 and 1, then we have a vertical compression by a factor of that number. Oops. Let's see. Vertical compression. Remember, in our grouping symbol, that's where our graph shifts from left or right. So if it's a positive C, it's going to go left that amount. And if it's a negative C, it's going to go right that amount. The D value is going to make it go up or down. It's the one that's not in the grouping symbol. So a positive D value is going to make our graph shift up, and a negative D value is going to make it shift down. And now we have a new component B. B is the frequency of our graph, and it helps us to find the period. So let's look at some more notes just underneath these on the same page. So B is our frequency, which we do need for the period. So in the next box, we have our formula for the period of the graph. So period is equal to 2 pi divided by B. Think of 2 pi as your standard cycle, because the unit circle goes 360 degrees, and 360 degrees is equal to 2 pi. So that's why the period of a graph is always taking that amount and dividing it by the frequency. Here's a good picture over here of a few more words. We have amplitude, which is how far it is from the midline to the top of our graph, and then the midline to the bottom of the graph. But notice those are the same distance, and we call that the amplitude. And amplitude is always a positive amount, since that's measuring a distance. The period of the graph is how long it takes for one full cycle to occur, whether it's sine or cosine. So like, for example, this one looks like a S. So that blue arrow right there indicates the period of this sine graph would go from just past -6 to 0. So it has a length of a little more than 6. Okay, the frequency is how many cycles occur within a given period. So if we're looking at this graph and we have a period of 0 to 1, we have a frequency of 4, because we have 1, 2, 3, 4 cosine graphs occur, or cosine cycles occurred in the period of 0 to 1. So that would be a frequency of 4. The midline is what it sounds like. It's the middle of your graph. If you drew a line, I'm going to get a highlighter. If you drew a line that helps you to separate, that you would have the same distance to the top, or your maximum value of your graph, that you would to the bottom. That is the midline of the graph. And then the same thing for this graph. The midline here shows I have the same distance to go to the top of the graph, and then I have the same distance to go to the bottom from the middle. Amplitude, like I said before, but this has its own box down here, is the vertical distance between a peak or valley and the midline. So my amplitude is how far I go from the top to the midline, or the bottom of the graph to the midline, and it should always be positive. If you have a negative in front of the function, that is a reflection, which is a transformation. But that's not the amplitude value. The value of it is just the absolute value of the A that sits in front of your function. All right, so we will look at the rest of these together. Those are the notes for graphing sine and cosine.